Hi there, my name is Eyal Carmi. In this video we will learn what scientific notation is and how to understand it properly. A main part of understanding it properly will be by means of converting numbers in the scientific notation to decimal notation. Let's get started with the real-world situation. We do a calculation with a calculator and get the result 5 times 10 to the power of minus 4. Unfortunately, we know nothing about this form of writing. It seems like a mystery to us. What should we do? No need to worry. 5 times 10 to the power of minus 4 is another way to express the decimal number 0.0005. This notation is called scientific notation and is a way of representing numbers as a multiplication of a power of 10. For example, the decimal number 0.0025 can be written in its scientific notation as 25 times 10 to the power of minus 4. The fact is that scientific notation is greatly used in scientific calculations, as well as used and displayed in calculators that most pupils and students use. That is why it is important to know how to read it and understand it properly. Let's talk about why the scientific notation is used. Many calculations involve numbers whose value is too large or too small. Writing those in the decimal notation is too awkward to write. Take for example a large number like 25 followed by 12 zeros, or a small number like 0 point followed by 8 zeros followed by 54. These numbers have too many zeros to write, so it's easy to miss a zero by mistake. But if we express these numbers in scientific notation, we can write these numbers as 25 times 10 to the power of 12 and 54 times 10 to the power of minus 10 respectively. As you can see, scientific notation is composed of powers of 10. Therefore, we first need to understand powers of 10. Powers of 10 means writing multiplications of tens as 10 raised to the power of an integer number. Let's see examples to really understand what that means. Let's start with 10 to the power of 0. Any number raised to the power of 0 equals 1. Don't try figuring why, just accept it as is. Don't worry about it not being intuitive, because this is the only exception in this example you'll see that is counterintuitive. 10 to the power of 1 means 10. 10 to the power of 2 means multiplying 10 twice, that is, 10 times 10, which is 100 in decimal notation. 10 to the power of 3 means multiplying 10 3 times, that is, 10 times 10 times 10, which is 1000 in decimal notation. As you can see, 10 with a positive power is larger than 1. 10 to the power of minus 1 means 1 divided by 10 to the power of 1, which is 0.1 in decimal notation. 10 to the power of minus 2 means 1 divided by 10 to the power of 2, which is 0.01 in decimal notation. 10 to the power of minus 3 means 1 divided by 10 to the power of 3, which is 0.001 in decimal notation. As you can see, 10 with a negative power is smaller than 1. Let's say we want to convert 10 to the power of 2 to decimal notation. The first key here is that we can always multiply a number by 1. That is, 10 to the power of 2 is the same as 1 times 10 to the power of 2. The second key here is that any integer number has a hidden decimal point to its right. Therefore, 1 can be written as 1.0, which gives us 1.0 times 10 to the power of 2. I would like to point out that a decimal point, also called a decimal separator, separates the whole number part from the fractional part. In this video, the decimal separator is marked as a point, but be aware that in some countries a comma is used instead. Continuing from where we left off, multiplying by 10 to the power of 2 means moving the decimal point 2 steps to the right and filling the spaces with trailing zeros. Doing that, we get the value 100. Note that the number of steps is determined by the power value, which is 2 in this case, and the direction of the steps is to the right, because the power is positive. The same process is done with negative power, except that the decimal point is moved to the left instead of to the right. Let's see an example. Let's say we want to convert 10 to the power of minus 2 to decimal notation. The first and second keys we already know. 10 to the power of minus 2 is equivalent to 1.0 times 10 to the power of minus 2. Multiplying by 10 to the power of minus 2 means moving the decimal point 2 steps to the left and filling the spaces with leading zeros. Same here, the number of steps is determined by the power value, which is 2 in this case, and the direction of the steps is to the left, because the power is negative. Note that after we moved the decimal point to the left as many steps as needed, there was no digit to the left of it. Having no digit to the left of a decimal point is the same as having a 0 to the left of it. Here is a table that summarizes a few examples with the complete steps to convert from powers of 10 notation to decimal notation for positive powers. Let's start with the first row. 10 to the power of 3 can be written as 1.0 times 10 to the power of 3, which is equivalent to writing 1.0 and moving the decimal point 3 steps to the right, and that results in 1000. Second row. 10 to the power of 2 can be written as 1.0 times 10 to the power of 2, which is equivalent to writing 1.0 and moving the decimal point 2 steps to the right, and that results in 100. Third row. 10 to the power of 1 can be written as 1.0 times 10 to the power of 1, which is equivalent to writing 1.0 and moving the decimal point 1 step to the right, and that results in 10. Here is a table that summarizes a few examples for negative powers. First row. 10 to the power of minus 1 can be written as 1.0 times 10 to the power of minus 1, which is equivalent to writing 1.0 and moving the decimal point 1 step to the left, and that results in 0.1. Second row. 10 to the power of minus 2 can be written as 1.0 times 10 to the power of minus 2, which is equivalent to writing 1.0 and moving the decimal point 2 steps to the left, and that results in 0.01. Third row. 10 to the power of minus 3 can be written as 1.0 times 10 to the power of minus 3, which is equivalent to writing 1.0 and moving the decimal point 3 steps to the left, and that results in 0.001. Let's practice. Represent 10 to the power of 17 in decimal notation. Pause the video and try to do the practice. To do that, we write 1.0 and move its decimal point 17 steps to the right. Here is another practice. Represent 10 to the power of minus 4 in decimal notation. Pause the video and try to do the practice. To do that, we write 1.0 and move its decimal point 4 steps to the left and get the result 0.0001. Now that you have the tools to convert scientific notation to decimal notation, let's say we want to convert 25 times 10 to the power of 4 to decimal notation. As noted in previous chapter, any integer number has a hidden decimal point to its right. Therefore, 25 can be written as 25.0. From here on, the process is exactly the same as explained in previous chapter. That is, we write 25.0, move the decimal point 4 steps to the right, which results in 250,000. Here is a table that summarizes few examples with the complete steps to convert from scientific notation to decimal notation. Let's start with the first row. 25 times 10 to the power of 4 can be written as 25.0 times 10 to the power of 4, which is equivalent to writing 25.0 and moving the decimal point 4 steps to the right, which results in 250,000. Second row. 4 times 10 to the power of minus 3 can be written as 4.0 times 10 to the power of minus 3, which is equivalent to writing 4.0 and moving the decimal point 3 steps to the left, which results in 0.004. Third row. 25.4 times 10 to the power of 5 is equivalent to writing 25.4 and moving the decimal point 5 steps to the right, which results in 2,540,000. Fourth row. 32.8 times 10 to the power of minus 3 is equivalent to writing 32.8 and moving the decimal point 3 steps to the left, which results in 0.0328. As mentioned before, scientific notation is greatly used in scientific calculations and in calculators that most pupils and students use. All scientific calculators can display this notation. Some of them may display it by default, some will need to be set. To see if your calculator displays the result in scientific notation by default, do the following calculation. 5 divided by open brackets and type 2 times 3,500 plus 3,000, close brackets, and press the equal sign. If your calculator is already set to express numbers in scientific notation, then you should see 5 times 10 to the power of minus 4. Let's do an example, so we can understand how to read scientific notation from our calculator, and how to type numbers in scientific notation when needed to. Let's write 5.2 times 10 to the power of minus 3 in a calculator. For this example, I used the Casio FX991EX calculator. Follow the steps from left to right. Each key press is highlighted in yellow. Below that, we can see the displayed result. Note that some calculators may display the result as 5.2 E minus 3. The calculator button that represents powers of 10 usually has one of the following symbols, depending on the model of the calculator. It could be times 10 to the power of x, or E, or exp. Now it's your time to try that in your calculator. Type these two examples and see that you get the results as expected. Your first try is to type in your calculator 1 times 10 to the power of 3. Your second try is to type in your calculator 5 times 10 to the power of minus 2 plus 0.03. This last chapter is entirely dedicated to exercises. 1. Write 10 to the power of 4 in decimal notation. 2. Write 10 to the power of minus 5 in decimal notation. 3. Write 5.28 times 10 to the power of 4 in decimal notation. 4. Write 0.3 times 10 to the power of minus 4 in decimal notation. 5. Write 2.0106 times 10 to the power of 2 in decimal notation. Pause the video and try to do the practice. Solution 1. 10 to the power of 4 can be written as 1.0 times 10 to the power of 4, which is equivalent to writing 1.0 and moving the decimal point 4 steps to the right, which results in 10,000. Solution 2. 10 to the power of minus 5 can be written as 1.0 times 10 to the power of minus 5, which is equivalent to writing 1.0 and moving the decimal point 5 steps to the left, which results in 0.00001. Solution 3. 5.28 times 10 to the power of 4 is equivalent to writing 5.28 and moving the decimal point 4 steps to the right, which results in 52,800. Solution 4. 0.3 times 10 to the power of minus 4 is equivalent to writing 0.3 and moving the decimal point 4 steps to the left, which results in 0.00003. Solution 5. 2.0106 times 10 to the power of 2 is equivalent to writing 2.0106 and moving the decimal point 2 steps to the right, which results in 201.06. Well done! I hope this video proves helpful to you, so next time when you come across scientific notation, you'll know exactly what it means. Thank you for watching. If you found this video helpful, please consider giving it a thumb up and subscribing to my channel. This will assist others in discovering it as well.